we have the objective, here's our learning goal. I can describe how changing the slope and the y-intercept affect the graph of a function. So what changes from one function to another? We have to be able to describe that. Sometimes you're going to graph them to support what you say, and other times you're not. So like in your homework, it says 20 through 27 with graphs. So you're going to describe the transformations, and you're going to graph the lines to support what your answer would actually happen. 29 through 37, even if it tells you maybe to graph, I'm saying you do not have to. And you'll notice that they are not on the graphs handout either, which should also be a reminder to you that you don't have to. Okay, so let's start out here with some stuff we need to know. A set of functions whose graphs have basic characteristics in common. Do you know what that's called? A family of functions. A family of functions. So you have this group, this set of functions that have basic characteristics in common, and they're called a family of functions. There's a linear family, there's a quadratic family, there's an absolute value family, there's all kinds of different types of families that each of them have their own characteristics. All linear functions form a family because all of their graphs have the same basic graph. And what is the graph for the linear function family? What kind of graph is it? Circle? A U? A V?
Straight.
A straight line. You've been graphing linear functions and you're all looking at me like, what? The graph of a linear function, you better get a line, right? And all lines are straight, by the way. Absolute value functions have what kind of a graph? Anybody remember? Back from another chapter? Of course, we don't retain our stuff. V's? Anybody remember what quadratic functions or squared functions have? U-shaped graph? Okay. Yeah. Okay. The most basic function in a family. Every family has one of these. The most basic function in a family is a parent function. So the most basic function, it's kind of like the one that all the others revolve around, is called the parent functions. And for the linear functions, that is f of x equals x. It's just that basic. F of x equals x. We know that f of x can also be called y. So another way to think of it is the parent function could be called y equals x. What's the slope of that function? 1. And what's the y-intercept? 0. So the parent function has a y-intercept of 0. It's going to go through the origin, and it has a slope of a positive 1. It's going to go up 1, over 1, up 1, over 1. Okay? The graphs of all other linear functions. So we have the parent function, and then the graphs of all other linear functions are transformations of the parent function. Oops, yeah, I need an S there before I make my F. Transformations. So we have the parent function. Any other linear function actually derives from the parent function being transformed. Okay? We're going to talk about 3 types in Algebra 1. That doesn't mean these are the only types, but these are the ones we're going to talk about. We're going to talk about translations, and we're only going to talk about vertical ones. We're going to talk about rotations, and we're going to talk about reflections. And we're only going to talk about reflections over the y-axis. Okay? So translation, what's it? When you hear the word translation, what's another word you can basically call a translation? You should know this from prior math classes. Hale? A slide. Mm-hmm. A translation is also known as a slide. Every point moves the same distance and the same direction. So the points slide either left or right, up or down. We're only going to talk about up or down slides. Okay? Rotation. What's another name for a rotation? What do you think of when you think about something rotating?
Spin.
A spin, but a turn. We're going to call it a turn. Okay? So, spin's not a bad word. We're going to call it a turn. A rotation is also known as a turn. In a rotation, because the line turns, the slope has to change. But the y-intercept doesn't have to change. In fact, it does not change. Because here's what happens. When there's a rotation, it has to rotate about a fixed point. One point cannot move. So for it to rotate, it's going to rotate about a point that cannot move, and every other point is going to move. But that point is not. So we're going to have it, that fixed point be the y-intercept, so it will not change. What's a reflection? What's another word for that? A flip, yeah, that one's a flip, or you can think of it as a mirror. Yep, there's a mirror image after you've had something flipped. A move across a line that produces a mirror image. Remember, we're only going to talk about the y-axis as being our line that it's going to flip over. Okay, so those are the three that we're going to deal with. Let's just do a little bit more than with this. Linear functions written in slope-intercept form. So when they're in slope-intercept form, we're going to decide what transformations happen. So for a vertical translation, what do you think changes and what does not? So we have this slide. What changes? Remember, we're talking about slope and y-intercept. Does the slope change?
No.
If a line moves up, every point on a line moves up, or every point on a line moves down, does the slope change? No. No. What changes? The y-intercept. So the y-intercept was here. It either moved up or it moved down, and so did all the other points do the same thing. So it's the y-intercept that changes, but the slope does not. And that's how we're going to tell just from equations whether a vertical translation happened or not. We're going to zero in on that y-intercept and say, did it change? If it did, that means there was a vertical translation that went on. For a rotation, what did it say changes for a rotation? Up above, what did it say? What did you say is going to change? The slope's going to change, but not the y-intercept. So we're going to talk about the larger the absolute value of the slope. In other words, the slopes are going to change. So it starts out as something, and in the other function, the transform function, it changes. We're going to take the absolute value of both of them, and we're going to see which one did that slope absolute value get larger or smaller. So if it gets larger, what happens to the line? The larger the absolute value of slope, the steeper it is or the less steep?
Steeper.
Yeah, if you rise more than you run, doesn't it get steeper? So we're going to talk, the steeper the graph, the larger the absolute value, the steeper the graph. So when we talk about a rotation, we're going to say that it rotated. We're going to say what it rotated about, and it's always going to rotate about the y-intercept. And then we're going to say what happened. Is that new line steeper or less steep? For a reflection across the y-axis, the slope is multiplied by -1. For a point to move from this side of the y-axis to the same distance to the other side, the slope just has to change to its opposite. So if the slope has been multiplied by -1, or another way to think of it is if the slopes are opposites of each other, then you have the reflection that happened. Okay? Any questions on the front side before we do move to the back? Okay, let's go back there then. We're not going to do any graphing in our notes. You are in your homework. We're going to just do the describing in words, and I'm going to show you what you have to have for support for those things that you say. And you have to be complete. So you know when you come back on Monday and you think your assignment's done, you might want to run it through the notes test to make sure it really is. Because here's the first thing we're going to do. We're going to take the two functions and we're going to identify their slope and their y-intercept, because those are the things that help us decide what happened. So we're going to say m equals b equals for that function. M equals b equals for that function. So here's f of x is our starting function. Starting function, that's what I almost said. Our starting function, and g of x is our transform function. What's the slope and the y-intercept of f of x? That's our parent function. 1 and 0. What's the slope and y-intercept of our transform function, our g of x? 1 and -4. Okay, what I like to typically do is I like to start with looking at the y-intercept and see, first of all, was there a translation that happened? So was this one translated? Did it slide? Did it move up or move down? Did the y-intercept change? Yeah. It went from 0 to -4. So we're going to say it translated, and don't say slide. Let's use the mathematical, not the AKA. Translated. You don't just say a translation happened. You have to say how far and in what direction. So it went down 4 units. You said translated down 4 units. Is only the y-intercept going to move down 4 units? Is every point going to move down 4 units? Every point has to move down 4 units with that y-intercept, yes, because the slope stays the same, but the y-intercept changes. Okay, how about, is there a reflection or a rotation that happened? How do we look to see if there's let's always look for a reflection first. Is there a reflection?
No.
How do we know there hasn't been a reflection?
Because the slopes are still the same.
The slopes are the same, they're not opposites of each other. They are exactly the same. So if they're exactly the same, did anything happen? No. If the slopes are the same, nothing happened, a rotation or a reflection. So the only transformation that happened in this one is a translation. It translated down 4 units. Okay, you do number 2 and number 3. Try those on your own, 2 and 3. Remember the first thing you have to do, identify M and B for both the functions. Okay, volunteer to do not finish number 2 for me. I started for you. Okay, come on up, Russell. Push your finger. Works better than my pens do for some reason. Okay, thank you. Anybody want to challenge him on it, or do you all agree with it? Translated up 3 units, number 2. Do we agree? Yeah, okay, volunteer for number 3. Go ahead, London. Okay, she's done. Anybody disagree with London? Want to challenge her on that, or you all agree? We all agree with that? Okay, why does it go down 7 units?
Because the other is -2.
Because it starts at 5 and it ends up down at -2, so the distance actually is 7. Okay, how come there's no other transformations happening in either of those? Why is translation the only transformation that happened? By the way, there won't always be just one transformation. Mara?
Because the slopes are the same.
Because the slopes stayed the same in them. So in 2, the slopes are the same, so that means a rotation or reflection could not have happened. In 3, same thing, the slopes stayed the same, no rotation or reflection. Okay, somebody's arm must have been helping right here. Okay, let's move on to number 4, okay? Okay, and number 4, what's the first thing you're going to do? What's the first thing you're going to do?
Identify the slope and the y-intercept.
Identify the slope and the y-intercept in each of the functions. Okay? Thought I'd see what it was like to be a lefty. Yeah, my husband's a left-handed too, so I was trying every now and then to do my hand. Not very good. So, do you agree with my slopes and y-intercepts? 3 zeros down here. Is there a translation? y-intercept didn't move, did it? Okay. Next thing I always look for is there a reflection? Are the slopes opposites of each other? Is there a reflection? No. Okay, is there a rotation?
Yes.
Okay, because the slopes changed, but yet they're not opposites. So we're going to say, okay, when we talk about a rotation, we're going to state it. We have two things we have to say. Rotated about, what was the fixed point that it turned around on? That point that does not move, it's stationary. So it rotated about, and remember, it's always going to rotate about the y-intercept. So what did it rotate about? 0, 0. So it rotated about 0, 0, and we have to talk about, did it get steeper? So is steeper or is less steep? So it went from slope of 1 to a slope of 4. Is our new line steeper or less steep? Is steeper because 4, absolute value of 4, which is 4, is greater than the absolute value of 1, which is 1. 4 is greater than 1, so we say it got steeper. Okay? You go ahead and do the next two because they probably are a lot like it. Volunteer number 5. You volunteer. Volunteer for number 5. Okay, Nick, again. Okay, thank you, Nick. Anybody want a challenge? I think there's only one thing they want to challenge, but there. How about, let's just, right now, let's like leave out the English part, but we are going to go back to it. Is the mathematical part right?
Did I say? Oh.
Wrote it.
When you're up there,
Wrote
it's
it.
different than on the
I know,
page.
it is, something
No,
just happens,
it's
yeah. So wrote it, instead of wrote it, I think he meant rotated, okay? Rotated about 0, 0 and is less steer, or steep, I think it is, steep? Okay, and is less steep, do you agree? Okay, why is it less steep?
Because
Slope went from
1 is greater than 1/3.
Yeah, 1/3 is smaller than 1, that's the new slope. We always compare the new to the old. So 1/3 is smaller than 1, not larger, so it got less steep, right? Okay, so now that we've got the English and the math part of this figured out, how about number 6? You guys just tell me what it is. What did you put on your papers for number 6? What happened in this one? I gotta make sure some other people in here are still alive. Kara, what'd you get?
Rotated around 0, 0 and steeper.
Rotated about 0, 0, or around, you said, I guess that works too. Rotated about 0, 0, and is steeper. Okay? You guys agree with Kara? Because why? Why is it?
Because 7/3 is greater than 3/5.
Yeah, because 7/3, the new slope is greater than 3/5, so it did get steeper, and it rotated about the y-intercept, which is 0, 0. Anything else happen? Okay. Okay, let's take a look at number 7 then. M equals B equals, M equals B equals. Oh, the first one is the parent function. That one should just roll right off of your brain. Slope is,
1,
B is,
0,
okay, slope of the other one is -1 and y-intercept is 0. Okay. Did it translate? Did it slide? No. We know it didn't slide because why? Well, not because they're not opposites. Why did it not translate? It does have something to do with the y-intercept though. They haven't changed yet. They're the same. The y-intercept didn't change. It did not move to a different location. So there was no slide that went on. How about a reflection? Are the slopes opposites of each other? Yeah, so we would say that this is a reflection. So here's how we say a reflection. Reflected across the, and we said we're only going to talk about reflections across the y-axis. So reflected across the y-axis. How about a rotation? Was it also rotated?
Yes.
Well, in the process of a reflection, there does really actually happen to be a rotation also, but you don't need to describe both of them when the slopes are opposites of each other. We can just state it as a reflection, okay? When they're opposites of each other, we can just state it as a reflection. Okay, so go ahead and do number 8 then also. What happens in number 8? Is there a translation? Anybody write anything about a translation? No? Okay, how about a reflection? Is there a reflection?
Yes.
Why?
Across.
-1/2 and +1/2 are opposites, yeah. So we're going to say it reflected, we know that. How about a rotation? No. Remember, if they're opposites of each other, if the slopes are opposites of each other, we're going to ignore the rotation part. We can just say it's straight out a reflection, okay? Every point is just going to reflect across and be a mirror image. That reflection took care of it. It looks like it did a turn too, but the reflection is all we really need to describe. So we could either, in reality, if you wanted to describe it as a rotation instead of a reflection, then that's what you would do. Okay. How about number 9? What's going on in number 9? M equals and B equals 2n -1. M equals -2b equals 3. Okay, first one. What's the first transformation? Remember, we look at the y-intercept typically first. Michaela?
Reflected across the y-axis.
Okay, it was reflected across the y-axis. You want to do the reflection first. Okay, we'll do that. Reflected across the y-axis because the slopes are opposites. Okay. Is that the only thing that happened, Michaela?
And translated upwards.
And it was translated up. Remember when we talk about a translation, we look at the y-intercept. It went from -1 to +3, so it went up 4 units. Okay, anything else that we need to say? No, remember that reflection for this one, in this case, it took care of it because the slopes were opposites. Okay, so not saying that you can't have all 3 things going on. Let's look at the number 10 here. We have M equals -1/4 and B equals 0. M equals +1 and B equals -2. Okay, where do you want to start? What happened? Let's start with the translation. Was there a translation?
Yeah.
Okay, because the y-intercepts are different, aren't they? Okay, so what did it do?
Down.
Translated down to okay, the slopes opposites of each other.
Down.
Is negative 1/4 the opposite of positive 1? No. And here's the deal. They're not opposites of each other, but they're opposite signs. So now, and you need to hear me on this, you know when you have to say both the reflection and a rotation, because we haven't been worrying about the rotation when one was positive and one was negative. Because why? What did we say?
They're the same.
Because they're opposites. And these are not opposites, but they have opposite signs. So when there's not opposites, but there are opposite signs, we had both a reflection and a rotation. Both happen. Okay? So it doesn't matter really which one we state first. Let's do the reflection first. It was reflected because of that negative. One is negative, the other one's positive. Not because they're opposites of each other this time, but because they ended up, we have the slopes end up opposite directions of each other. So that means there had to be some sort of a reflection that went on. And then, last but not least, there was a rotation. And it's rotated about the y-intercept, but remember, we already moved the y-intercept. We moved it down 2 units. So we've already translated it down, we've reflected it, and now we're rotating it. So what's it going to rotate about?
0, -2.
0, -2. It's going to rotate about 0, -2, because we moved it down that y-intercept. And is what?
Steeper.
So 1 compared to the absolute value of negative 1/4, which is 1/4, it got larger, so is steeper. So all kinds of things happen to this one. Okay, why don't you go ahead and see if you can do number 11 on your own. See what happens. Let's see what function you get. Write a function g of x. Your function should be called g of x to describe the new graph. The graph of x is given to you and they tell you what they want you to do. Kayla, are you done? Okay, you're coming up here to show us what you got. Come on up. Show us what g of x should be.
This is my
Okay, you guys keep working while Kayla's doing it. Don't keep copying her. Think for yourself. And then you can see if you agree with her when you're done. Or if you want to challenge. Okay, Kayla got g of x is equal to negative 3x. Everybody agree? Sadie's got the same thing. What about a few others? Okay. Why? Why is it that?
Because we put -7, so we go up 7 units and make it disappear.
So for g of x, our b value has to be what then?
0.
0, okay. That's the translating 7 units up. Okay. Why else? I don't,
Because it has to reflect.
has to
And so
reflect.
the slope would be opposite.
So the slope has to change to the opposite of 3, which is negative 3. So now when we write our function, we write negative 3 in for the m, 0 in for the b. When we clean it up, what do we get? That's right. There's our function for g of x. Good job. Okay. This is the kind of stuff you're doing at homework along with graphing. So get out a sheet of loose leaf paper. Whew. Whatever.